Good morning, dear students. Today we will discuss multivariate analysis. Till now we have discussed univariate that involves one variable, then bivariate involving two variables. If you have more than two variables, then there is multivariate analysis. Let us see what multivariate statistical analysis basically is. It is statistical method that allow the simultaneous investigation of more than two variables. See, I just explained even in the last presentation that you might have so many variables for the study. Maybe let's suppose you have got 10 variables for your study, but sometimes we study variables separately, sometimes we study all the variables all together, right? So when you are studying actually just one variable at one time, you are applying some analysis on one variable at a time. That means univariate. When two variables are present in one analysis, then that is bivariate analysis. But when you try to study more than two variables at one time in one analysis, that means when you are studying them together apart, they all the variables make one part and then you are studying them. Maybe you might try to understand their effect on each other, or maybe their dependency, or maybe whether they are associated or not, maybe about the but about anything, any related thing to those variables. If there are more than two variables which you are studying for one particular analysis, which you are trying to take them together and trying to analyze, that would be your multivariate statistical analysis. This can be classified like in two categories: dependence methods and interdependence methods. All multivariate methods would be like, are some of the variable dependent on others? If they are dependent on others, then it would be like dependence method. If they are not dependent on others, or maybe they are interconnected, their own qualities are such that they are interdependent, then it would be interdependence method, right? Dependence and interdependence. Dependence methods are a category of multivariate statistical techniques which explain or predict a dependent variable on the basis of two or more independent variables. Like we discussed in regression analysis, discriminant analysis is also one of the kind of regression analysis, but for non-metric data, right? We'll discuss them in detail in upcoming slides. So dependence analysis means you will be having at least one dependent variable and one independent variable. Then dependence methods, these can also be divided further. How many variables are dependent, right? If there is only one dependent variable, several dependent variables, or multiple dependent and independent variables. On that also, we can bifurcate them in these analysis, right? If there is only one dependent variable, then whether the data is metric or non-metric. For metric data, and when you have just one dependent variable, it would be multiple regression analysis, right? And when it comes to only one dependent variable with non-metric data, then it is your multiple discriminant analysis. Or you can say that when you have interval and ratio scale, you will be using regression analysis. And for the similar study, if you did not collect interval or ratio scale data, you have ranked the things, then you will be going for multiple discriminant analysis. If you have several dependent variables for dependence methods, if you have metric data, that means interval or ratio scale data, then you will be going with multivariate analysis of variance. That means multivariate ANOVA, and it is popularly known as MANOVA. If you have several dependent variables and not metric data, then you will be going with conjoint analysis. This is kind of replacement for MANOVA for non-metric data. Then how many variables are dependent? Till now we were saying that we have one dependent variable, then several dependent variables. Now we have multiple dependent and multiple independent variables, right? We have more than one dependent and more than one independent variable. In that case, whether your data is metric or non-metric, you will be using canonical correlation analysis. Then interdependence methods, category of again multivariate statistical techniques. These methods give meaning to a set of variables or seek to group things together. This is basically done when you have got multiple variables and you might want to collaborate them. For example, you have got 6 7 variables and you want to combine them in just 2 variables, right? In that case, you will be using interdependence method. Like you can check which variables are interdependent on each other, and then you can make set of 4 questions in one set of variable, make set of 3 question in another variable, make set of 2 question in another variable, coming out to be 3 variable out of 9, right? This way you can do. For interdependence methods, again, we'll be asking whether your inputs are metric or non-metric, right? For metric data, we have got 3 analysis. Number 1, factor analysis, then cluster analysis, and then multi-dimensional scaling. And these all are for metric data. So let us start with multiple regression. This was our dependence analysis, right? This is basically an extension of bivariate regression. We have already discussed it in the last presentation, but still this is that was your bivariate regression. That means involving only 2 variables, and one was dependent, another was independent variable. So here equation would change. Allows for the simultaneous investigation for 2 or more independent variables and a single interval scaled dependent variable. Here you would be having only one dependent variable, and you can have more than 2 independent variables. This would be the equation for multiple regression analysis. Here y is equal to a plus beta 1 x1 plus beta 2 x2 beta 3 x3 plus up to beta n xn. N can be 2 3 4 5, anything, right? Till now, in case of bivariate regression equation, we were using this particular formula till here only. Y is equal to a plus bx, because we had just one independent variable and one dependent variable. Now we have multiple independent variables, so we have taken this x thing like this, x1 for first independent variable. For second independent variable, we have taken x2, and up to nth independent variable, we have taken xn, and bn are their covariates. This way you would be representing the equation like this. Over here, y was equal to a plus b1 x1 plus b2 x2. The same way, y is equal to, this is the value of a, then this is the value of b1 into x1 plus b2, value of b2 into x2, the plus value of b3 into x3, right? This way you would be presenting the equation. Then you will be stating r squares value. For example, in one particular example from our last presentations, I have taken it, it was 0.845, and f value is this and p value is this. That means we'll be checking p value, whether the results are significant or not. Then we'll be checking f value, we'll be reporting it that f value is significant. That means the model is fit. We'll be reporting r squares value, like how much the equation is explaining, and then we'll be reporting the equation, so that if we want to check anyone's value, like either y, either x or x1 x2 x3, if we want to calculate any value among them, then we can calculate it with the help of other values. For example, you would be having value of x1 x2 and x3, you can calculate y value. If you have value of y, x1 and x2, then you can calculate the value of x3. Like this, you can calculate anyone's value here, any variable's value, right? Then we have multiple discriminant analysis, statistical technique for predicting the probability of objects belonging in 2 or more mutually exclusive categories, dependent variable based on several independent variables, like this. All the while similar equation is there, as in like regression equation. Z is applicant's discriminant score is equal to b1 x1i plus b2 x2i up to bn xni, and b1 b2 up to bn are here discriminant coefficient for nth variable, and x1 x2 up to xn are applicant's value on the nth independent variable. So this way you will be calculating the value of discriminant analysis. And for example, through various independent variables, you will be checking the value of z, and through that you will be making conclusions whether this would be happening or not, yes or no. That kind of the values you will be getting for z 0, 1, 2, 3. For example, you might want to check whether someone would be going for outing this summer or not. Right, you might be a travel agent or something, and you want to check so many things about a person, whether he has traveled before, what is his salary, how many people are there in his family, right, how much he wants to travel, what are his favorable locations to travel, and how much others are earning in the family, and so many things are there. And when you will be putting these values here for x1 x2 up to xn, b1 b2 and up to bn, then you can calculate the value of z. Z might be you can set up a criteria for values like 0, 1, 2, 3, 4. In between the values would tell you that whether the person would be going for the trip or not. This would give you an idea like what kind of the people you should approach for going for a trip, right? Then your canonical correlation, as the name suggests, it is basically trying to check association between the variables, but here we have more than two variables, basically two or more criteria variables, that means dependent variables. Then multiple predictor variables, that means again independent variables. And then an extension of multiple regression. In multiple regression, we had just one independent variable and multiple independent variables. But here we have got multiple dependent variables as well. That is why we are studying it separately from regression analysis. It is basically linear association between two sets of variables, wherein one set would be your dependent variable and another set would be your independent variables. This would be the equation for canonical correlation equation, like z would be equal to a1x1 plus a2x2 up to anxn, and w would be your another dependent variable, for which the equation would be like this: b1 y1 plus b2 y2 up to bn yn. This is you can see the equation is very much similar with regression analysis. Then your factor analysis. This is now your interdependence approach, right? A type of analysis used to discern the underlying dimensions or regularity in phenomena. Its general purpose is to summarize the information contained in a large number of variables into a smaller number of factors. And that is why it is even known as several factor analytical techniques. For example, like I just discussed, if you have 10 variables in hand and you want to reduce those variables, for example, by making a questionnaire, for example, you have got 50 questions and you want to reduce the questions, right? In that case, you can apply factor analysis and you'll get to know which are the similar set of questions. You can either put them together, for example, a set of 5 questions in one table, set of 6 questions in one table, and then you can frame one question for them, major question for them. Or you can even do that, like you can remove a few questions if you feel like that they are giving you the similar result. You can remove 1 or 2 questions. You can reduce the number of questions in your questionnaire with the help of factor analysis, and you can even set them systematically with the help of factor analysis. So basically it is what it is doing, large number of variables would be turning into small number of factors. For example, you have 50 variables, it might give you a conversion of 5 set of factors like this. We have got height, weight, occupation, education, source of income, right? If you randomly talk about them, then height and weight look similar, and these are basically related to the size of a person, right? Occupation, education, and source of income, these sound similar, and these are part of your social status, right? Height and weight can also be social status, a part of social status, but still if you have got two, you want to divide these five into two factors, two set of factors, then you'll be concluding with them only that like size can be fit in with height plus weight, and occupation, your education, and your source of income would make up to social status, because source of income has nothing to do with height in most of the most of the jobs, you can say, right? Source of income has nothing to do with weight until and unless you are doing some physical work, right? And the same way, occupation doesn't have any relationship with height and weight until and unless you are going with modeling or something like that. And education has again no concern with height and weight, but yes, education might have some concern with your occupation as well as your source of income, and occupation also has relation with your source of income, right? So these are related things. This way you can categorize number of variables into smaller number of factors. Then it is cluster analysis. This is actually a body of techniques with the purpose of classifying individuals or objects into a smaller number of mutually exclusive groups, ensuring that there will be as much likeness within the groups and as much difference among groups as possible. It is more or less like factor analysis, you can say. In factor analysis, what we were doing, we were trying to put variables together and forming one factor, right? In the same way, cluster is also similarly done. Like you will be ensuring that like variables would form one group and different categories would be made, right? Then multidimensional scaling, a scaling technique, statistical technique that measures objects in multidimensional space on the basis of respondents' judgment of the similarity of object. Basically, you will be again, this is a kind of factor analysis. It would give you, it would generate a lot of factors for you. It would help you in, discriminating, in deleting some questions from your scale or your questionnaire. Then multivariate analysis of variance, that is MANOVA, statistical technique that provides a simultaneous significance test of mean difference between groups for two or more dependent variables. Like when you have just one variable and you are going to check two categories, you will be using t-test. When you have got two variables or say more than two categories, then you will be using ANOVA. When you have got more than two variables and n number of categories, you will be using MANOVA, right? All formulas would just alter a little bit, like in case of bivariate and multiple regression, other things would remain the same. That's it for multivariate analysis. Now let us discuss some true false. Number one, multivariate statistical analysis permit the researcher to consider the effects of three or more variables at the same time. Yes, this is the actual definition of multivariate statistical analysis. So it is true. Second is, the variate is a mathematical way in which a set of variables can be represented with one equation. Yes, it is true. So done, true. Third is, the basic types of multivariate techniques are metric methods and non-metric methods. Is it? Basic type of multivariate techniques are dependence and interdependence techniques. So it is false. Fourth is, multidimensional scaling is a type of interdependence method. Yes, we have just discussed it in the last. So it's true. Fifth is, the type of measurement scales used will determine which multivariate statistical techniques are appropriate for the data. Yes, up to some extent, this is very important. The type of measurement scales, it defines, it tells you, it will determine for you that which is the appropriate multivariate statistical technique for this data analysis. True. Sixth is nominal and ordinal scales are referred to as metric scales. Is it? Interval and ratio scales are metric scales, and nominal and ordinal scales are non-metric scales. So it is true, false. Seventh is in multiple regression, the dependent variable must be continuous and interval scaled. Yes, dependent in multiple regression, this is the first and foremost condition, that your dependent variable must be continuous and interval scaled. So it is true. Eighth is multiple regression analysis includes a single independent variable but several dependent variables. Is it? It's actually the opposite. Multiple regression analysis includes single dependent and more than one independent variables, right? So it is false. Ninth is several dummy variables can be included in a regression model. Yes, you can include as many dummy variables in regression model. So it is true. Yes, let us discuss some questions now. Self-assessment questions. Compare and contrast dependence and interdependence techniques. List the statistical techniques for both. What do you mean by dependence technique? You will be defining dependence technique. What are these? Right, which are dependent on, when one variable is dependent on another, right? That is dependence technique. And when variables are interconnected, that would be, so many variables are interconnected, then it would be a interdependence technique. You can list them as per metric and non-metric data. Then when you have one dependent variable, when you have two dependent variable, when you have several dependent variables, and when you have several dependent and independent variables, you can categorize it like this, again in the form of metric and non-metric data as well. List all of them and then define them in single lines. Then interdependence techniques, you list all of them and then define it one by one. Then second is list the steps in interpreting a multi-regression model. How would you interpret multi-regression model? First of all, you will examine the model F test for significance. You will be checking the F value and then P value against it. So that means you will be checking whether the model is fit or not. If that is not significant, then you will not be considering the analysis, right? Because analysis is insignificant and you will be reporting accordingly. Second is examine the individual statistic test for each parameter estimate. For example, you have got three independent variables and one dependent variable. That means you'll be getting four values, one for intercept and three for three independent variables. For example, for x1, x2 and x3, right? Those values would be coming under b1, b2 and b3, right? So you'll be checking all the values. Again, you will be checking their p value as well, whether they are the significant values or not. Then you will be checking the value of r square. This is generally said that examine the model r square, whether model is fit or not. Then you will be checking in the last collinearity diagnostics, such as variance inflation factors for each variable to detect multi-collinearity, whether two or more variables are multi-collinear or not. For example, you might have taken a person's age and number of years he's working in the company. They might come like as in multi-collinear problem in the analysis. So those particular variables needs to be checked up, right? Then third is explain how ANOVA models differ from ANOVA models. ANOVA or MANOVA, a model represent a form of your general linear model, right? ANOVA can be extended beyond one-way ANOVA to predict a dependent variable with multiple categorical independent variables, right? Whereas MANOVA is a technique that predicts multiple continuous dependent variables with multiple independent variables. So the independent variables are categorical, although a continuous control variable can be included in the form of a covariate. So that's the different, like they can be categorical or metric. It depends on whether you are going for ANOVA or MANOVA. Then explain how, why and how a business researcher uses factor analysis. Like I mentioned, even at the time of presenting this, factor analysis is generally used to reduce the number of variables in a questionnaire, or to combine variables in set of factors. Like we have just mentioned one example, like height and weight can be combined in size of the person, and occupation, their income level, their education might be combined in one thing, which is professional or your social status, right? So this is how we'll be using factor analysis. Then last is explain how cluster analysis can identify market segments. Cluster analysis basically is a multivariate approach for identifying objects or individuals, right? Just like factor analysis, more or less like factor analysis, that are similar to one and exhaustive, one another in some respect, right? It classifies individuals or objects into small number of mutually exclusive groups, right? And objects are individuals, and these would be assigned to groups, so that there is a great similarity within the group and much less similarity between two groups, right? For example, like we have just mentioned, size and social status, these groups would be extremely mutually exclusive within and exhaustive groups. These two should not be having any variable which might be a part of the other one, right? So this way they should be they should be having great similarity within the group. For example, height and size, height and weight would be very similar, and it should be having minimum possible similarity with elements of other group. For example, your occupation, your income level, and your education level, right? So the cluster should have high internal homogeneity and external heterogeneity. Cluster analysis facilitates market segmentation, yes, by identifying subjects or individuals who have similar needs, lifestyles, or responses to marketing mix. This is generally mostly used for marketing segmentation. That's it. Thank you. Our next presentation would be on report writing. That we have done everything, almost everything. Now we started with your research process, then what kind of the analysis can be there, what kind of the research process would be there, research objectives, hypothesis, then analysis, how would you collect the data, what kind of the research design you will be following. Everything we have done. Now the last step is report writing, right? So we will be discussing it in our next presentation, and that would be our last presentation for this subject as well as for the unit.